In this video, I will talk about how to count how many possible outcomes there are in a procedure. So the first concept I want to talk about is the basic counting principle. So what does it say? Now let's give an example. Suppose that there is one coin and there's one dice. Now, what you do is toss the coin twice. And then you roll the dice once. So you do these two procedures here. Then how many possible outcomes do you have that you would have? Now let's look at it from a tree diagram perspective. So when you first toss the coin the first time, you can have possibly two outcomes. Because it's either head or tail, because it has only two sides on the coin. Now, when you toss the coin second time, you can have possibly two outcomes as well, right? By looking at just tossing the coin the second time. But factor into the first time you toss the coin, you could have a head the first time, and then you could have an outcome of head or tail again in the second time. Or the first time tossing the coin you get a tail, then you could have also two other outcomes, right? When you toss the coin second time, which is a head or a tail again. Okay, so how many possible outcomes you might have right now? 4. So it would be either head or head tail or tail head or tail tail. So now you are going to roll the dice once here. Okay, so how many possible outcomes that you possibly have if you roll the dice once by just looking at rolling the dice? There are 6 sides in the dice, so only one side will show up. So you could have possibly 6 outcomes. But factor into account that you roll the dice already twice, right? So the first outcome could be that, oh, you have head and 6 possible outcomes in rolling the dice. 1, 2, 3, 4, 5, 6. And then you could have head, tail, and then you have 6 possible outcomes in rolling the dice. So 1, 2, 3, 4, 5, 6. And then you could have tail, head, and a 6 possible outcome in rolling the dice. 1, 2, 3, 4, 5, 6. And then you could have tail, tail, and then 6 possible outcome in rolling the dice. 1, 2, 3, 4, 5, 6. Okay, so we finished these two procedures here. So how many possible outcomes there are? Well, if you look at the tree diagram here, you see 6 here, you see 6 here, you see 6 here, and you see 6 here. So you see 4 of the 6. Then you can just say that, okay, so 6 times 4 times, right? That is 24 possible outcomes. Okay, yes, that's the answer. But what if you don't have the tree diagram? You don't see a tree diagram. Then how do you determine that it is 24 possible outcomes? Now, let's look at it this way, right? You toss the coin twice and you roll the dice once. So let's look at it like this. How many possible outcomes you can have when you toss the coin the first time? 2, right? Because you get either head or tail. Now, look at the second time that you toss the coin. How many possible outcomes that you can possibly have? 2 again, because there are only 2 sides on the coin. then you just multiply by 2, right? So overall, you have 4 possible outcomes, right? Because you roll the die twice. Oh no, because you toss the coin twice. Now you talk about rolling the dice. Okay, now you think about just rolling the dice by itself. How many possible outcomes when you roll a dice? There's 6 sides in the dice, so there's 6 possible outcomes, right? Only one side will show up. Okay, so that's it. Then you just have to see, right? It's 2 times 2 times 6. What's that equal to? 24 possible outcome. So you can still figure out the possible outcomes without looking at the tree diagram. Okay, so that is the basic counting principle. Now, the second concept I want to talk about is permutation. Let me do it here. Now, let's give an example. Given 7 letters, A, B, C, D, E, F, and G. How many ways can you arrange a 7-letter word with these letters? Okay, so when I say word, I don't mean that it has to be a valid word. I'm just asking, how many ways can you arrange these 7 letters? How many ways can you put these 7 letters together? Now, let's think about it like this, okay? So you have A, B, C, D, E, F, and G, right? Trying to put them together. Now think about that. When you're trying to put this together, arrange these letters, when you begin, right? Let's say you have 7 letters, so then you have n letters here. So in this case, n is 7. You have 7 letters here, right? So when you begin arranging the first letter, how many choices do we have? You have 7 choices because you can pick any of this letter, right? So you have 7 choices to begin with. Now, once you pick one letter here and start arranging, how many choices do you have left? You have 6 left. So you can see it like this, right? So what you have left is 7 minus 1, right? Because you already take 1 out, right? The first letter out. So you have 6 left. And if 7 is n, then this is n minus 1, right? Okay, so the second letter you can choose, you have 6 options. So you multiply by 6. Okay. After you choose the second letter, how many letters left do you have as choices? 5, because you already take away 2, right? You only have 7 in total. Then, in this case, right, you have 7 minus 2, because you already take away 2 here, right? So that is 5. So this is n minus 2, right? 7 minus 2. Then times 5, right? There are 5 possible choices you can choose here. Okay, then after you pick 3 letters already, right? Then the next one that you want to put here, to arrange here, how many choices you have left to pick? You have 4 choices left, correct? Because you already use up 3 letters, right? Because you only have 7 letters in total. So this time, right, you already use up 3 letters. So you have only 4 choices left. So this is n minus 3. Then times 4, right? Okay, so after finishing putting 4 letters together, could be any of these 4, right? Then how many letters you have left to choose from? 3, right? So 7 minus 4, you have 3 left. So this is n minus 4, right? So times 3. So after you arrange 5 letters already together, how many letters you have left as a choice that you can arrange? 2. So next would be, right, 7 minus 5. You already use up 5 letters, right? So you have 2 choices left. But this is n minus 5. So you only have 2, right, left that you can choose from. At the end, after you use up 6 letters, how many more letters do you have left over? That's really only 1, right? That's the last letter. It could be any of this letter, but it's the last letter. So, right, you use up 6, you only have 1 left. So that is n minus 6. Now, how many ways is this? Okay, what else can you write this as? This is really 7 times 6 times 5 times 4 times 3 times 2 times 1, right? So another way to look at this and to write it in another way is 7 factorial. Okay, so now you can take a calculator and then calculate what 7 factorial is equal to. Okay, so now, okay, let me calculate this. Seven factorial is equal to 5040. Okay. So now, if you have to arrange all these 7 letters, right? Then you have 5040 ways to arrange this. Okay. Now, what if the question changed to this? Oh, before I talk about that, let's look at it like this, right? N is 7, right? So 6 is n minus 1. And 5 is n minus 2. 4 is n minus 3. 3 is n minus 4. 2 is n minus 5. 1 is n minus 6. So I can also write this as, right? If 7 is n, right? I can also write this as n times n minus 1 times n minus 2, right? Like from here, times n minus 3 times n minus 4 times n minus 5 times n minus 6. Well, since 7 is n, right? So this is just 2 and 1. Okay, so what is that equal to here? Okay, I can write like this, right? N times n minus 1 times n minus 2 times, at the end, times 2 times 1, right? So that is equal to n factorial. So I can write like this. Now, next, what if I'm going to talk about this? The question is, choose any of the 4 letters from that 7 letters here. Okay, choose any of the 4 letters from the 7 letters here. How many ways you can arrange a 4-letter word with these 4 letters. Now again, right? It doesn't have to be a valid word. I'm just asking how many ways you can arrange these 4 letters. Okay, now let's look back at this. You have A, B, C, D, E, F, and G. Okay, 7 letters. But you can only choose 4 letters from here. Okay, so how would it look like? Now, first of all, you have 7 letters here at the beginning. When you're trying to choose, they have 7 choices. So you still have 7 choices to begin with, right? Okay, after you use up 7 choices here, how many choices do you have left? Sorry, after you use 1 choice here, how many choices do you have left? 6, because you already used up 1 letter. You only have 6 letters left for you to choose from, right? But this is your second word, so you have 6 letters to choose from. Now you are putting the third word in, okay? Then after you use up 2 of them, how many letters you have left? You have 7 in total. Then you should have only 5 left, right? So you have 5 to choose from. 5 letters to choose from. Now, this is the last word you can put in, right? Because you can only use 4 letters, arrange 4 letters. And how many letters do you have left over to choose from after you use up 3 of them? You will have 4 left. Okay, that's it. So this is the possible outcomes because you can only arrange 4 letters. Right? The question asking you to just pick 4 letters and arrange them. How many ways can you arrange them? That's it, right? There's no more after that. Then you can calculate this, right? Okay, so use your calculator. 7 times 6 times 5 times 4. Right? You have 840 ways. Okay. That's a lot less way than using 7 letters. Yes, that makes sense. Okay, now, what is the difference between this one and this one here? I guess you can notice that, right? It's missing this portion here. So, to go from this to this, I can also write it like this. 7 times 6 times 5 times 4. Okay, so this part here, right? Times 3 times 2 times 1. All divided by 3 times 2 times 1. Of course I can write it that way, right? Because the magenta numbers will just cancel out and you have left only 7 times 6 times 5 times 4, just like this one here. So what do you see here? Well, the top is really 7 factorial. What is the denominator? Well, this is 3 times 2 times 1, right? So you can see that it follows the format of this, right? Then this is just the 3 factorial. Right? So 7 factorial divided by 3 factorial. Okay, how do we get this number 3? Well, we know that we can use the letter n to represent 7 based on what we talk about here. Then, how do you represent the number 3 with letters? Now, you know that there's 3 ways left. 3 possible letters left. In order for you to have 3 possible letters, in order for you to have 3 letters left, you choose 4, right? Out of 7. So the top is 7 factorial. You basically choose 4 out of 7. So if take 7 minus 4, right? And then factorial. That's how you write it. Well, apparently this is 3, right? 7 minus 4 is 3. So in the question, right, you choose 4 letters and you know the total letters you have is 7. So now you can write an expression for this, right? So what's that equal to? Well, 7 is n, right? N factorial. Divide by, of course, right? 7 is n. So n minus, we use letter r to represent this number 4 here, right? Minus r, and then factorial. Well, basically we're saying that choosing r objects in n. Okay, so how do you denote this formula? Okay, so we denote it as, right, that's a permutation, and that's n here and subscript r here. So that's how we denote this. Well, if n is equal to 7, r is equal to 4, over here, we can also see this as p, now n is 7, r is 4, right? Is equal to this. Right? We can say it like this. We can express it like this. Okay, so here's permutation. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.